All right, notes 4.2, dividing radicals. Dividing radicals, okay? All right, so it's similar in a sense to the multiplying because, all right, the radicals being divided must have the same index. Well, that was true when we were multiplying. It was also true when we were adding and subtracting. Okay, so that's important. All right, and then in terms of like the main process, you're going to divide first, then simplify. Okay? And just like with, which is basically the process we did with multiplication. We multiplied first, then we simplified. Okay? And just like with multiplication, you're only allowed to divide stuff that's in front of the radical together and then stuff that's under the radical together. Okay? All right, and then, of course, since the radicals have to have the same index, that index is not going to change. That index is not going to change. Okay? So let's look at a couple of problems together. Okay? All right, so you can call this practice or examples or whatever you want to call it. All right, and we're going to jump right in what I call the deep end here. All right, I've got 24 times the 4th root of 240 over 3 times the 4th root of 5. Okay, now again, we're just starting with constants. We will work our way up to problems with variables. Okay? All right, so what parts, because we're going to divide first, what parts do you think we're allowed to put together? What things are we allowed to divide to get us going? The coefficients, which in this case are what? 24 and 3. So we're going to divide those. What is 24 divided by 3? 8. Okay? Now, the other two pieces, do they have the same radical? Yes, they're both an index of 4. So we are allowed to divide those two pieces. Okay? And the radical stays the same. The index stays the same. What was 240 divided by 5? I know a lot of you typed that in already. 48. Is that right? Yeah. I thought that's what I heard. Okay. Now, is it a division problem? No, it is not. It is a simplifying problem. So how do you simplify these things? Factor trees, okay? And in order to circle a set, how many of a kind do we need here? 4. Thank you, Grady. And Jamie. Oh, maybe it was Kate. Nope. I know I heard Grady. I know Aylish has been on top of it today. The boys in the back, they've been helping me out too. All right, I don't know, I'm hearing you. All right. Is that what it is? You sound like a girl? Okay, I don't think so. But you've been told that? Okay, I hear you. All right, so hopefully we're okay with making a factor tree at this point. Yes? And I need how many of a kind to make a circle? 4. I have just enough 2's. All right, what do I do with that 2? Multiply it by the 8. So I end up with 16 in front. What's the rest of my answer? fourth root of 3. All right? You feel like that's a hard jump from what we were doing? Okay. Slide back up here a second. Do number 2. All right, now you know I'm going to throw some variables in there this time. All right, so let's do a cube root of 486 m to the 12th over the cube root of 3m. Okay, do we have to worry about dividing numbers in front this time of the radicals? Nope, we just have to worry about dividing the numbers under the radicals. All right, so we divide first. What is 486 divided by 3? Let's just start with the number part. 1 what? Thank you, 162. All right, now who remembers how to divide with letters, with variables? Yes, you subtract the exponents. All right, you subtract the exponents. Did you say that? Awesome. Okay. All right. So remember when we multiplied, we added the exponents. So when you divide, you subtract the exponents. All right, and you always leave it wherever the bigger one was. So if there's 12 on top and 1m on the bottom, when we subtract them, there's how many on top? 11. But when I divided, 162 is technically on top, so it's all on top. We won't even worry about the bottom just yet. Like, there will be leftovers on the bottom later. That's the whole rationalizing the denominator. We'll get there. That's why we're breaking it into 2 little pieces. Okay? All right, so that's it for the dividing. Now what do I have to do? Simplify. Awesome. Awesome. Simplify. Okay. So I got to break down the 162. Anybody have a pair for that? 2 and 81, good. And then let's see, 81, that's a perfect square, 9 and 9. But that's not enough, so I keep going. All right, what am I circling sets of? 3. And I have one set of 3s. How many sets of 3 can I make out of the m's? All right, 2 would be 6. 3 is 9. Okay, so I can do 3. All right, remember, if you need to write them all out and circle the sets, that's fine. All right, but I definitely have leftovers. What number is left over? What's my constant? 6. And then if I used 3 sets of 3, I use 9 m's. How many are left over? 2. All right? Questions? Okay, so I am going to give you, let me do one more. And then I'm going to give you a couple that are actually going to be, you're going to include it in your homework when you take a picture, okay? All right, so let me do one more together, just because it's a little different. See what you can figure out for this one. All right, so I have 2 times the cube root, 24, m to the 4th, n to the 5th. And then on the bottom, I have the 4th root of 81, m to the 8, n to the 4th. You want this, Keith? All right. What's wrong with this one? They're not the same index. They don't have the same index, so I cannot divide right away. I can only divide the ones that have the same index. So in this case, I actually need to simplify first. And then maybe I'll have stuff in front that I can put together. like in front of each radical. All right? Because it's only the stuff underneath the radical that you can't put together when there's the index is different. Okay? So, it's basically like doing two completely separate problems. I need to simplify the top and then simplify the bottom. Okay? So, if you want to write them out off to the side and then kind of work through them individually, you certainly can. All right? In fact, this is something that you guys, all right, should definitely be able to do. The separate simplifying, work on that for a minute or two, and then we'll come back together. Okay, what did you guys break the 24 down into? 8 and 3, and then the 8 keeps going. Good. And then the 4 keeps going into a bunch of 2s. Okay. And then, of course, don't forget to cross out the ones that broke down. All right, do we have enough to take something out? Yes, because I only need how many? 3. All right, so what number is going to end up being in front of this whole thing? 4. Okay. Do I have enough m's to take out a set of 3? Yes? How many sets? 1. All right, do I have enough n's? Yes. How many sets? 1. But I have leftovers. Okay, I have leftovers. What's left over? 3. What else? M into the second. All right, now where is that going to go in terms of my original problem? On top. I'm going to come back over here, and I'm going to put all that on top. All right. Then I need to do the other one. Okay? Kevin, what did you break 81 into? Just give me 2 numbers that multiply to be 81. And? Okay, and then each one of those? All 3s? Okay, just checking. All right, do I have enough to take anything out? Yeah? But I need how many of them? All 4. All right, so what's going to go in front? 3. All right, how many sets of 4 can I make out of my m's? 2. Will there be any leftovers? No. How about my n's? Will there be any leftovers? So are there any leftovers? All right, so then there's no more 4th root. It's gone. And so I put this thing, I come back over here, and I just put 3 m squared n on the bottom. Okay, so now I don't have to worry about 2 different radicals, right? Because I just have the cube root on top. Am I going to be able to divide anything into that cube root? No, because the bottom doesn't have a cube root. But the stuff in front of the cube root can be put together with the other stuff that doesn't have a root on it. Okay? Now, can I do anything with 4 divided by 3? No, but what about the letters? We just talked about that. What do you do when you're dividing letters? Subtract. And you need to subtract to wherever the bigger one is. Okay? So I have 1 m on top and 2 on the bottom. When I subtract, how many are left and where is it? 1 on the bottom. What happens when I try to subtract the n's from each other? They cancel out. If you have exactly the same amount, they cancel each other out. Right? When I subtract 1 from 1, I get 0. None. Okay, so then what do I do with the cube? What do I do with that cube root then? Just bring it down and put it on top. And then I'm done. Okay? Then I'm done. Now, you're not going to have many that complicated, but like you need to pay attention. If the indexes don't match, guess indices is the plural for that. If they don't match, then you need to break them down first. And maybe you'll have some stuff not under the root or the radical that matches. Okay? Before I give you a couple practice problems, I'm not going to work this one, but I just want to show you, you may see a problem where the radical is over the entire fraction. You may see a problem like that. I'm telling you, you will. Okay? One big one over the whole thing is the same thing as a little one on top and one on the bottom. Okay? I just want you to know they mean the same thing. Okay? Is everybody okay with that? All right. So what I'm going to do is I'm actually going to write up a couple of problems for you to do. And they are going to be part of the homework pictures that you submit. Okay? And then the other part will be in Alex. Okay? Because Alex does not even have problems like this. I don't know why, but they don't. And you do, this is definitely an SOL tested skill, so I need you to practice it. Okay? And so you want to put it somewhere where you can at least take a picture of just that part, all right, for homework 4.2. All right, so go ahead and label it and make sure you have room. If you want to start a new page, you're more than welcome to do that. All right, so this is just the first half of homework 4.2. So you can call it 4.2 part 1 if you want. Okay? And these are all division problems so that you can do some practice. Okay? So let's see. Start off with some with no variables. Okay. 1, 2. And yes, I'm still recording because I want, when people go back and watch the recording, they have to know that these are homework problems. Okay. All right, so there's the first two. All right, here's the next one. All right, that one I just talked about with a big radical, I'm going to do that one. Just remember, you write it as one radical on top and one radical on the bottom. Okay? And then I've got one more. So just 5 problems. You should be spacing them out on your paper so you have room to work. And you need to write them down because you're not going to be able to see them the whole time. You got to slide it up. What are y'all waiting for? Oh, I'm sorry. All right, get that first line copied, and then I'll slide it down and get number 5 up there. All right, and then, like I said, I only have 5 for you. So here's number 5. Again, I'm doing one big root. Just means you need to make it 2 smaller ones. Now, I will tell you on this one, I mean, you are welcome to divide first and then put the radical. It's up to you. Okay? So that's what I want you to practice for a little while. That's the first half of your homework. Okay? I'll give you a little while to work on that.